Hi, so my name is Luke Hoban. I'm a program manager at Microsoft working on the Chakra team that builds the JavaScript runtime that ships in Internet Explorer and in Windows 8 and various other places. I've had the opportunity to be at this conference several times previously talking about interesting other things I've worked on with C# and with F# and things. But over the last year and a half, I've had the opportunity to be working on JavaScript in particular. Be working with the ECMA standards body on what the work is happening towards the next version of ECMAScript, which is ECMAScript 6. So after Galad's talk, I'm sort of here to talk about that other web programming language that several people use, and what some of the sort of more incremental things that are happening in the ECMAScript standard that will push that forward for the broad base of existing JavaScript developers. So to sort of put some of this in context of sort of the history of where ECMAScript's been, ECMAScript was first standardized not long after a couple of years after the first JavaScript engines were built, and was rapidly evolved through the few years following that. But then the work on ECMAScript 4, which happened over sort of the intervening years in the mid-2000s, was ultimately ECMAScript 4 aimed to sort of go and add a lot on top of JavaScript and change some sort of fundamental things about the JavaScript language. And that work was ultimately abandoned after there wasn't sort of broad consensus on the direction of those additions. And instead, ECMAScript 5 was sort of adopted by the standards group at the end of 2009. And so you'll notice there that there's about 10 years during which between the ECMAScript 3 and ECMAScript 5. And that period was also where a lot of renewed sort of interest in JavaScript and in this whole sort of web programming thing was happening. In addition, that was also a period where a lot of this work on fast JavaScript runtimes was happening. And so the ability to write sort of larger applications that performed at user expectations was happening during the same time frame. But ECMAScript 5 itself was a fairly sort of incremental set of additions on top of ECMAScript 3. And didn't go and sort of, in big ways address some of the biggest pieces of feedback about where the language had some sort of some unmet needs for application development in libraries. And so some of the features that we're looking at in ECMAScript 6 are going to be the things that sort of go that step further and try to address some of the larger needs. And so that's what I'm going to be talking about today is ECMAScript 6, which, as you see here, is sort of being tracked towards having a standard adopted in ECMA by the end of 2013. So specifically on ECMAScript 6, I'm going to today be kind of just talking about going into sort of a detail on each of the different proposals, or not quite all of them. I'm going to be touching quite a few, but not 100%. But each of these proposals is an area of work that's currently targeting being part of this ECMAScript 6 standard. And so there's several of these areas of work going on, each sort of championed by different members of the standards body. And the sort of a key milestone in the ECMAScript 6 development process was reached last May, where the committee agreed on sort of an approximate upper bound for the set of proposals that were going to be under discussion going forward. So previously there'd been a lot of just broad discussion, a lot of new ideas being brought in. There's now sort of a list of proposals that are the things that are on track to be part of ES6. And of course, this might change if these don't continue to converge, or if there are design issues found as more progress is made. It's definitely possible that this list will change, or some of the features will change in meaningful ways. But this has sort of been a key milestone to have an upper bound that is going to be tracked towards by all of the participants in the standards group. Alan is also here and is the author of or the editor of the spec. And so another key milestone was reached near in the late part of 2011 when Alan put out the first sort of iteration of ECMAScript 6 draft specs. And so this is starting to sort of in fully detailed, rigorous spec language try to capture some of the ideas from these proposals. And so far, the spec drafts only cover a couple of the proposals, but the spec Alan is working hard to continue to integrate the ideas that are being more fully fleshed out into this spec. Another issue that has been a source of a lot of interesting discussion and is really key to how you evolve a language like JavaScript and a runtime like JavaScript that is so heavily and broadly used in such a sort of a peculiar deployment environment as the web is the versioning experience. And so the decision that has been reached at this stage is that there will not be any explicit versioning opt-in. Just like there has always been in JavaScript and always been in the web platform, your code will roll forward and run on the newer versions of the runtimes automatically and gain access to new features that it can use. So any script tags you have in your existing applications can start to use these features of ES6. This obviously means that the bar for breaking changes becomes extremely high. So where there's the desire to, that part of the language is kind of awkward, we want to fix that. That's not a tool we can just go and say we want to change the behavior of all these things. If you want to have a clean versioning experience for a language that's as broadly used as JavaScript, you need to have a very high bar for where you make breaking changes. And another interesting issue with this is on the web, of course, people want to deploy applications that run across a broad range of browsers. And syntax is not feature detectable. So if you have a syntax feature, you can't say, if while loops exist, then I'm going to go into this branch, otherwise don't. And so one of the common features that's used in sort of the DOM and in JavaScript programming for versioning is feature detection. Syntax obviously doesn't have that tool available directly. There are some tricks you can try to play. But it does mean that so a lot of the syntax features that I'll talk about here presumably will have a longer time to adoption because they'll need to wait for broad adoption on the web until people are ready to be able to target only the browsers that have those features. So many of these things are long-term investments for the web platform, doing the work now to make sure that in the future there are some of these foundational elements available. But that's effectively three of the key ideas there. So for the rest of this talk, I'm just going to go into detail. We're at a languages conference, so I want to just give you a view of each of the different proposals that are being discussed that are sort of significant. And I'm going to go through these in sort of three categories. And the first category is sort of the features targeted at library builders, the things that sort of extend the actual capabilities of the system in a meaningful way, that allow you to build richer or different kinds of libraries than you were able to, at least easily, in the past. So the first of these, there was actually a question about proxies in the previous talk. One of the features being added into ECMAScript 6 at the library level is the ability to create proxies. The idea with a proxy, now one of the things I meant to mention is since most of these features, proxies is actually an exception to this, but most of these features don't have fully fleshed out implementations yet. So normally when I'm doing a languages talk, I like to just do it through demos all the way through. I can't do that yet for ECMAScript 6, so I'm going to do this all in slides, but I'm going to use my red pen to try and highlight things. So proxies, we can basically create these handler objects, which define a set of sort of these meta operations that you can do on an object. So I can do things like I can get a property of an object, or I can define a property of an object. And once I've defined a handler that describes how each of these operations happens, I can create a proxy over an object using that handler. And what this gives me back is sort of a new object, which sort of has a little proxy in between that object and the underlying object. And so it can see any operations done, and it can intercept those operations. It can do logging around those operations. It can do anything it needs to sort of change the behavior of what those operations do. And this allows a lot of new sort of scenarios. It allows creating sort of virtualized objects. It allows creating sort of transparent layers that do caching and logging and various things like that. And it also enables you to define objects whose behaviors are more general than what a general JavaScript object that's defined in user source code can do. And so where previously there's been a big gap between what a host object can do in JavaScript, like a DOM object, and what a user object can do, proxies allow libraries to sort of define objects that have the same richness as host objects. And so this is sort of a key enabling feature for a lot of libraries and frameworks. And we expect to see several interesting things built on top of proxies. Another interesting concept is private names. So one of the one of the sort of issues that comes up a lot with JavaScript is the difficulty of associating private state with objects. There's various techniques you can use for sort of encapsulating private state enclosures and making sure that you hide it that way. But if you want to actually associate sort of per object private state, there's no sort of direct way to do that in JavaScript today. So private names extend sort of the core object model. Every JavaScript object is a sort of property bag, and those property bags are indexed today just by strings. So every property has a string name, and you look that up in the property bag, and it gives you back the value of the property. With private names, the core object model actually allows you to have both strings and these private name objects be the keys into your objects, keys into your properties. So here we can create a new name, and we'll pass it the string key, and that's mostly for debugging purposes, so that in debugger I have some nice name to associate with my private name. And now I can use that as the thing that I index into an object with. And so because this is a private name, it will look that up by sort of object identity on that private name. And I can then reference it later inside the other parts of my class. So here I actually have some sort of private state associated with my class that my constructor sets up, and then my methods can reference. And in typical sort of JavaScript style, we use our standard encapsulation technique of a closure around the whole thing to mean that this key variable that needs to be referenced by object identity is only visible within the scope of this class definition. So here I've sort of created what would typically be a true private name, but you can also build things like internal on this mechanism by sharing that key variable across the entire compilation unit, for instance, but not exposing it out to other parts of the program. So now from outside, when I look at my object, I create a new class C here. C, if I look it up by the string key, there is no property named key, so I get undefined. In fact, there's no way for me to access this property as a sort of external user of this object. It's only visible if I know to index it by that object, and I don't have access to that object. So this is sort of a fundamental ability to provide sort of private properties on objects, which enables in the future to build sort of layers of syntax and things like that on top of this, and also allows code generators targeting JavaScript to emit true privacy if they need to. So this is a nice building block for libraries. Another library building block is binary data. And so JavaScript historically has not had the ability to sort of work with raw binary data in the system. And there's obviously many scenarios where you want to do this. I have several of them mentioned at the bottom left there, where you're even on the web, you're in situations where you're wanting to process and deal with data in binary formats. And there's the very easy ability, lots of new HTML5 APIs for getting a hold of various forms of binary data. And actually, browsers have already started shipping some of this support. Many browsers support what's called typed arrays, which are the ability to basically create, using the array buffer, we can just allocate a block of memory. So here I'm allocating 8 bytes of space. And then I can create views over those. So I can create an int32 array view over my block of 8 bytes. And that will give me back an array of int32s that are a view on that thing. So you can think of this as sort of a malloc and a cast to a different element type. What we're extending that with in ECMAScript 6 is the ability to define sort of higher-level struct types and new kinds of array types. So whereas typed arrays had just a few built-in kinds of binary data, ECMAScript 6 will provide the ability to define your own. And so here you can see we can define, using some primitives like the uint32 struct and the uint8 struct, we can define our own structs on top of those. So we can define a point2d struct type, which is going to have a field named x and a field named y, which are both uint32 structs. And then I can create a few others like color and pixel here. And then I can ultimately define my own array type. So I can define a pixel array to be an array type whose elements are pixels. And then I can allocate one of those, initializing it just from a JavaScript object here. But I could also initialize that from laying a view of this pixel array over a segment of some binary data that I pulled in from a file, for instance. So I can import a file and lay a view as a pixel array over that, and then get very efficient reads against that block of memory. So this allows a lot of sort of the low-level programming. The typed arrays is already being used very effectively by many libraries out there that do low-level programming, and the structs will give a sort of a much more sort of convenient way of doing a lot of that work. I think this is the last feature in this sort of library builders camp. Iterators and generators, probably there's a fair bit of familiarity with these concepts from other programming environments. There's a few separate concepts being touched on here. So the first is generalizing. JavaScript has a for-in loop, which iterates the properties, the property names of an object. But oftentimes this is not exactly what people want when they want iteration over an object. They want some sort of higher level notion of what it means to iterate an object. And so the for of iteration allows sort of a generalized form of iteration over objects. And so the object can define its iteration behavior, so Fibonacci here, can define its iteration behavior by providing a property, and in this case we're actually using private names, so we're using a special name called iterator, which is the name that the name object that knows what iteration behavior is. And any object that has an iteration behavior will return its iterator, and that will be what's actually iterated over in this loop. So very similar to what you might have with sort of an IEnumerable or an iterable in C# or Java. The other aspect of this is the ability to do yield from within a function star. And so this, very much like C# iterators and not entirely unlike the await kind of features, gives me the ability to actually include sort of yields within a function that will allow me to write sort of straight line code, but which can sort of be can return values intermediately through the execution. So this gives me the ability to write these iterators in a very natural style without having to go and do sort of the state machine decomposition of the iterator itself. And so this sort of is the foundation for, in C#, this is the foundation for some of the tools like LINQ. It also can be a foundation for some improvements to asynchronous programming. And so these features are another tool that library builders can use to expose new kinds of capabilities in their libraries. Okay, so that's sort of the piece focused on library builders. The next segment is sort of for developers, for people just writing a lot of code today. And here, most of these features are effectively syntactic sugar. They're things which aren't new capabilities of the system, but they're taking the things that people are doing today and trying to give them a more succinct, more easy to understand syntax. So a first simple example is destructuring. So there's an awful lot of code today which just sits there and tries to rip various properties out of an array or out of an object and assign them into local names. So destructuring just gives me a simple way to bind. So here I can sort of bind the array 1, 2, 3, and I can say A is going to be bound to the first element and B is going to be bound to the third element. And this just sort of binds those variables into the corresponding values from the right-hand side. We can do this over both arrays and over objects. So over objects, we sort of use the same object literal style. And so this basically will say if I get my AST node, no matter what kind of object that is, if it has an op property, I'm going to bind A to the op property. And if it has an LHS property, which itself has an op property, I'm going to bind B to that sort of nested property inside there. If any of these things don't exist, the variable is going to be bound to undefined, and so I don't get sort of error checking at this point. This is in JavaScript edition. This is just going to bind to it if it's there, and bind to undefined if it's not. And I'm still going to have to write my checks to make sure that that if I expected there'd be a value, that it was there. But it gives me a very quick shorthand for decomposing a structured value into pieces that I want to go and look at. This can, of course, be used in any binding position, so as well as being used on the left-hand side of a var binding or other kind of binding construct. It can also be used in parameter positions within calls, so for instance here. Another sort of key JavaScript concept is object literals, used for all sorts of different use cases within JavaScript programs. And so a key place for improvement is actually to expand the sort of richness of what object literals can express. And so the enhanced object literals proposal adds a few separate concepts into object literals. The first one is object literals today can't specify what their prototype is going to be. They always have object.prototype. So an object literal, when it's born, is always just directly inherited from object.prototype. So the backwards pipe operator, which there's a lot of vigorous debate, and Alan would be happy to discuss with you, I'm sure, the interesting debates around what this operator should look like or be called. But the backwards pipe operator gives me the ability to specify that when this object literal is created, this object here will be its prototype. So it allows me to set the prototype at object construction time. And this is very useful for a lot of the sort of desugarings of class patterns or various other object constructions in the language. Another concept being added is the ability to directly define methods. Today, one of the very, very common things in object literals is having, toString, colon, function, open paren, close paren, open curly, and then you write your body of your method. This is just a simple shorthand for that, where we can just write the method directly, but it means exactly the same thing. One key ability that it gives me is the ability to use super. And so super is actually going to be bound in this context based on what the prototype was. So that the fact that we know the prototype at construction time means we can associate super with that in the correct way. Now this left pipe operator also means I can do some new things which have historically not been possible in JavaScript and which are often requested. Like I could create my own sort of derived kinds of arrays. Arrays have special, unique behavior in them, and I can get that behavior into my own arrays by defining my own array prototype, which itself inherits from array prototype, and then saying that my array literal actually has that in its prototype chain. So I can extend the prototype of my arrays through this technique. So one proposal that was just gained consensus actually at the TC39 meeting last week, and so this is sort of hot off the presses, and I may even be premature in putting it up here and claiming that it's part of ECMAScript 6, but I'm going to go for it because I think this is one that is very valuable and has been a hotly demanded feature, and we're seeing it now appearing. It's been in C# for several years. Java 8 has a very similar feature. CoffeeScript, one of the very popular tools that compiles to JavaScript, has it. We saw in Dart they have it. So this is being sort of broadly adopted in languages like JavaScript. Here we see a couple of examples of how lambdas work inside JavaScript, inside ECMAScript 6 proposals. So the idea is we can write, expression-bodied lambdas. We can also write statement-bodied lambdas, like in this example. In the C# style, we don't have to parenthesize if there's a single parameter, but we do have to parenthesize when there's multiple. The one sort of more unique to JavaScript aspect of this is that the fat arrows, or lambdas, have lexical this. And so one of the most confusing concepts in JavaScript for a lot of JavaScript developers is the way that this is bound. And so inside, when you declare a normal JavaScript function, your this is bound to the this that was dynamically passed to the invocation of your function. For callbacks, that's normally not what you want. And when you're writing a callback, for instance, in this case, we're writing a callback to the for each function. We don't actually want to get a new this. We want this, and this to mean the same thing. We sort of expect them to sort of intuitively from our training in many other programming languages. And so with ECMAScript 6 lambdas, these do in fact mean the same thing. The lambda itself does not introduce a new binding to this dynamically. It's not the same as a longhand function in that sense. And so this means that when used for callbacks, you get exactly the sort of behavior that you expect, and you don't have to deal with these crazy tricks that JavaScript programmers use today to try and avoid this kind of problem. And so in a sense, lambdas become the tool you use for callbacks, and longhand functions, or the method syntax we saw for object literals, becomes the tool you use for declaring methods and method-like functions. Okay, string interpolation. Gilad touched on this in the Dart context, and this is also a feature that the ECMAScript 6 is expecting to include, is the ability to have strings which use string interpolation. So this new form of string uses backticks, and so we use backticks in our strings. It doesn't have any fundamental escapes, so /n, for instance, is not an escape to a /n. This is truly literal. It can also have new lines. This by itself is a very commonly requested feature in JavaScript. It's the ability to have multi-line string literals. And then, as Gilad mentioned, we have this escaping mechanism with $, that allows us to escape and splice in things that are bound in the sort of current lexical scope. So here the name variable is bound to Bob, so we're going to splice in the value Bob here. So it's just a shorthand for doing some sort of string concatenation operations. The one slightly more unique aspect of this is the ability to actually prefix with a function. So in this case, we were defining someone else in a library somewhere has defined a get function. And this get function actually gets to participate in the way that string concatenation gets done. So it actually gets passed all of the different pieces of this string. And then it can do whatever sanitization, or it can throw errors if it doesn't like certain things it saw, or it can do sort of URL encoding of the components that need to be stuck in URL encoded locations. So it can participate and control the way in which that string concatenation gets done. And then it can return whatever object it wants. So in this case, it can sort of construct an HTTP GET using this string and doing all the right encodings. And then we can just pass the result of that, the callback to call. So this gives us some sort of interesting ways of leveraging string interpolation, and in particular helps us build some tools for more safe string concatenation operations. And then the sort of last one in this set, some simple operations that are sort of also very commonly requested. One of the very, very common things you see in JavaScript libraries is trying to sort of say that certain values have default values, and so you'll see a prelude at the top of a function that sort of describes all of how to handle whether if values are undefined, assigning them default values. And so now there's a way to just sort of specify that directly in line. So we can say that the default value for the y parameter here is going to be 12. And so if it's not passed in, it's going to come in with a value 12. REST parameters give me a way. JavaScript has always had a arguments object, which I can get a hold of from within any function. It has several issues that cause some problems. It's not a true JavaScript array. It has some behaviors where it sort of has kept in sync with the actual parameters themselves. And so there's some performance overhead with that that's hard for engines to optimize. And so REST parameters aims to provide a more natural way of doing this, which just says, I want you to give me all the remaining parameters as a true JavaScript array. And then I can use that in the exact same way I would use an array. And so here, this array y would be given the string hello and the boolean true. Sort of the opposite of that is the spread operator, which says that when we call this function, I actually want to expand out this array and pass it as individual parameters. And so this is sort of a more direct way of doing what you can do today with sort of function.apply in JavaScript. But instead of having to write out these sort of funky library-based things, we can do more directly using the spread operator. And so obviously sort of those last two are, in a sense, sort of duals to one another. Okay, so then the last segment of this is sort of the features that are really targeted more towards scalable applications. So these are the things that are going to try to address some of the issues that were being brought up earlier, where JavaScript, as it sort of grows up, needs to have some more tools for building larger applications. And so in a sense, for many sort of large application developers, the ones I'll talk about now are potentially going to be the ones that have some of the biggest impact on day-to-day development. So the first of these is actually to address another one of it. I mentioned that this binding for functions was one of the big points of confusion for JavaScript developers. If there's another big point of confusion for JavaScript developers, it's the scoping of var declarations. So in JavaScript, all var declarations are hoisted to the function scope. And so blocks do not themselves create new scopes in JavaScript today. Let is basically a new binding form that binds to a block scope. And so this gives it the same kind of behaviors you expect in many other C-style languages and that a lot of JavaScript developers just expect and are accidentally bit by. And so the idea for let is that it really is sort of the replacement in a sense for var. And so it's the tool to use to get the same kind of behavior you might expect in terms of binding. So in this example on the right here, we can declare an x in this outer block here. It is okay then to declare an x in this inner block, and it is not the same x. So that's different from JavaScript. If these were both vars, I would have one x shared across both of these scopes. But it's okay to declare an x here. I cannot, though, declare another x down here. So this will actually give me an error and tell me that I'm sort of redeclaring the x variable. And so this will be an error that's actually caught early. So when my page loads before anything runs, this error will get caught. So easy to detect these errors. You won't likely ship with any error like this because nothing in your page will work at all. The other aspect here is const, which has the same sort of block binding behavior as let, but is single assignment. So I can't then come here and say x equals foo, because this x bound inside this scope is const. So this is both sort of useful for indicating intent and for catching some errors, but also opens up several potential performance opportunities for engines, which are hard to infer at the moment. Okay, so the next one, modules, is one of the potentially largest impact features, I would say, in the set of proposals here. And that it can potentially address several of the sort of larger scale application development issues and provide a tool for sort of at the large scale helping to structure your programs in a more reasonable way. So modules allow me to declare a module named math, for instance, here. And inside that module, I can declare a set of exports. I don't have it here, but I could also, of course, have as many other bindings as I want inside the body of this module, and all of those are purely local to that module, just like the sort of standard module patterns that people use in JavaScript today. But when I export these variables, they're now available on that module itself, on module math. So I can do several things with the module. I can just reference it as a variable, and I can access those members on the object. So it gives me a way of just sort of a more declarative kind of object literal form in a sense. But more importantly, I can do sort of various forms of imports on that module. So I can do the sort of standard, C# using kind of thing, where I import star from math, and this binds in my current scope. All of the names out of math are now bound here. So now I have access to unqualified sum and pi because I imported them from my math module. But in typical sort of JavaScript fashion, we want to be able to actually do remote code loading and that kind of thing. And so here, and this is actually obviously very common, it was mentioned earlier that there's a whole plethora of interesting tools out there, library-based tools that do various forms of module loading. And there's several of those that have become very popular over the last several years. And one of the goals for ECMAScript 6 modules is to provide a sort of common syntax mechanism for that captures most of the core benefits of those systems. And so here, for instance, we say we can bind this JSON2 module. We're actually going to bind it from this URL. And so that means I'm going to, when this code loads to be compiled, it's actually going to go off and hit that URL and do whatever's needed to bring back that source. And then once that comes back, I'm going to compile and execute this block of code. Now that's sort of implicitly async. I'm not going to block a thread or block the UI or anything waiting on this to happen. But I am going to, once that code is loaded, and once all my dependencies are loaded, then I'm going to compile and execute myself as well. One of the notable things here is that this is sort of syntax, but the ECMAScript 6 spec itself is not going to specify exactly what these strings mean. And several other aspects of modules are going to be sort of delegated to a module loader, which is going to be a general abstraction in libraries. And so each host will get to define its loader behavior, its default loader behavior. And that's important because as we've seen JavaScript being used in many contexts besides just the web platform, there's very different sort of code loading mechanisms in the browser versus in Node.js or a server-side framework. And so the way that these strings are interpreted and what paths are used to look these up, that's all up to the host. And so a node host, for instance, can use this mechanism, but can indirect it through whatever lookup paths it needs to on the local machine. Okay, so classes. It took me this long to get to classes, which are of course one of the most commonly sort of raised things in JavaScript development. Classes are very controversial, I think, in the sort of JavaScript world. The ECMAScript 4 had a proposal around classes, and ever since then there have been several variations of class proposals. The classes, as they're in the ECMAScript 6 proposals today, are what's being referred to as maximally minimal. So they're trying to be as minimal as possible, just a simple sugar over what people are doing today in JavaScript all the time, but while still providing enough value that they're going to be useful for a broad range of use cases. And so I think there's continuing discussion about whether this is whether that maximum minimal point is going to be met. But the current notion of classes is I have the ability to define a class, so a new keyword class, and it can also declare its base classes. So I can declare that I extend from a new class here like 3.mesh. My class can define a set of methods, and these are just setting up prototype properties. So here the update method is just going to be skinnedmesh.prototype.update. And so this is just doing exactly the kind of code that a developer would write today to write a class by themselves manually in JavaScript, but I'm doing it with some more declarative syntax here. These methods can also, like in the enhanced object literals, these methods have access to super, and because we know what the base class is, we can construct that super call correctly. And then the other notable thing is that the constructor method is special. So the constructor name here is treated as special, and that constructor method is the one that's actually going to be used when I call new skinned mesh. It's actually going to be this code that runs at that point. And so the constructor is just the core constructor function. It also has access to calling super, so it can call it the super constructors. Notably, though, there's no declarative syntax here for the instance properties. And so just in typical JavaScript style, I just imperatively assign those properties onto my this parameter. So this is trying to formalize some of the sort of core concepts of what are the standard patterns for class-based programming in JavaScript today, and that's providing some simple syntax for those. And just as one last feature, I couldn't leave without talking about Unicode. Another feature that was just gained sort of consensus within the committee at last week's meeting was a set of sort of incremental extensions to have better Unicode support within JavaScript. And so the libraries that are being added and the additions in this space, I'll just cover a few of them here. One is there's been just to actually set the stage for this, JavaScript traditionally has not supported characters above the base plane, so above the 16-bit character point. And so Unicode obviously supports a broader range of characters. And so things like this character here, actually, if I type, put this code into a JavaScript environment today, it'll tell me that the length of this string is 2, because it's actually 2 16-bit code points. It's a supplementary code pair. This causes a lot of problems for actually working with strings that include these kinds of characters in JavaScript today, and there's not the facilities to work with full Unicode strings conveniently, and several of the libraries that try to fill in the gaps have several issues because of this. So the idea is to add several sort of concepts into the libraries and into some of the language constructs, which make it possible to work with strings as their full Unicode strings. So for instance, here, this regular expression, there's a new flag, a new U flag, which is a Unicode flag, and that will change the behavior of some of the regular expression components to behave in the sort of proper Unicode handling way. And so here, the dot operator, which matches any character, will now match any code point. And so that means that it will actually match this entire character as 1 instead of matching just the first code unit of that. And so this does mean, for instance, that now matching a dot can give you a string of length 2, which may have been unexpected previously, and that's why this is all being done under opt-in flags. Also, some things like the ability to write full 16-bit Unicode literals, which is just handy if you're working with this stuff directly. Some new libraries on string to do things like instead of char code at, we can do code point at to actually get the full full 21-bit code point at a particular index in a string. And then we saw earlier that we have iterators now in the ECMAScript 6 proposals. And so there's also going to be the ability to iterate over a string. Iterating a string will actually give you back the code points. And so the combination of regular expressions and the iterator over strings should make it possible to reliably work with Unicode-based strings in a much more easy way here. And there's several other pieces to this proposal that sort of are more about fixing some parts of the spec to deal with the Unicode characters correctly. But I'll also note that the goal here is obviously to be able to support better development of sort of global applications using JavaScript. And along those lines, there's also a separate activity that isn't directly part of ECMAScript 6, but is going on in parallel in TC39 to develop an I18N library for JavaScript, which is also helping with those goals by adding several other libraries for more higher level global operations. So I think I'm just out of time. So if we have time for a few questions, I'll take some Q&A. For those who want to find out more about these, wiki.ecmascript.org has details of all the proposals I've talked about today, plus some I wasn't able to. And there's a discussion list available for folks who want to sort of get involved in the discussion of where some of this is going at esdiscuss at mozilla.org.
Cool. So we don't have time for questions, but we'll take one or two anyway.
Okay.
So I'm really fascinated and curious about private names.
Yeah.
So when a private name goes out of scope, do like the fields associated with that private name and objects get garbage collected?
Well, when the objects, so then the fields are tied to the lifetime of the object, just like any field would be.
But are they tied to the lifetime of the name as well? So, like, if you can't possibly have a reference to that name anymore, maybe you could...
I believe the spec will not say anything about this. The spec generally doesn't say anything about this anyway. I believe, in principle, an implementation could sort of drop the values. It could drop references to the values of those properties if that name was no longer reachable. But I haven't thought deeply about whether that's the case.
No further questions, Your Honor?
All right.
Thank you very much.
Thank you.